at the product rule, and the product rule is also part of lesson 10, so we're sort of putting two lessons together for double diff. Now, the product rule looks at something that's pretty cool. You can, normally, you'd have to separate out all the terms by expanding, then you differentiate each separate term. So a term separated by either a plus or a minus. Now, in this case here, for instance, you've got two brackets. So, and I'll just highlight what we're looking at. X times by x plus 3. So we've actually got two brackets here, and they're not separate terms. They're multiplied together. So what we do at the moment is we'd expand the brackets, then we'd differentiate. Now, there's actually another way of doing this, and the rule's called the product rule. The product rule is able to differentiate even when terms are being multiplied together rather than added or subtracted. So here's how the product rule works. If you've got y is equal to, and you've got function f of x multiplied by function g of x, then, and I'll change the color on this, let's make that one green, then this is how you can differentiate. So if you want to differentiate, you get you differentiate f of x and you multiply it with g of x. Then you do the same thing. You add together with the differential of the g of x times by just the normal original function f of x. Now, sometimes, and I prefer this notation myself, you can go, okay, let's just say instead of f of x, let's call it u, and let's call it v. Then if you want to do this, you can call it, and I prefer this here, y is equal to u dash v plus, and then you can go v dash u, or something similar to that. Now, there's heaps of different ways of showing this. Best way to do this is through practice, okay? Now, what I'm going to do, I'm going to write up the your terms here, okay? So 2x plus 1, 3x plus 2, and then this one down here, f of x is equal to x squared plus 4x on 2x take 3. So here we go. Oh, that's going to say B. Let's have a crack at A here, the worked example, then you can have a go at the your term. So first thing, I'm going to practice using my f of x notation on this one. This is my function f of x, and this is my function g of x. Now we know if we want to differentiate, and what color should I choose? Let's get purple. dy by dx is going to be, and then we differentiate that times by that, plus we differentiate the second one and times by the original. So here we go. Let's differentiate f of x. We can see if we differentiate f of x, it becomes 5. Okay, and if we differentiate, and then we just get to put a normal function there, g of x, like that. Plus, now we move on to g dash x. So let's differentiate g dash x, that becomes 2. And then we're going to times by f of x, which is 5x minus 1. Next thing is we can expand it. But before I do, I'll just show you what I'm doing here. If I highlight this 2, that's the gradient function of g of x. So I've just differentiated this 2x plus 3 bracket, and out pops it 2, because that's the differential of 2x plus 3. And same over here, if I want to differentiate f of x, basically the gradient of that function there is just 5, and that's where that 5 comes from. Let's expand out and see what happens. I've got 10x plus 15 plus 10x take 2. Our answer, if we bring all our terms together, is that it's 20x plus 13. Now what you can do to confirm your work is you can expand this and see if it does make the same thing. 10x squared plus 15x take 2x take 3. We've got 10x squared plus 13x take 2. And let's differentiate, it becomes 20x plus 13. So you can see here it's made the same work. Now, when these get more tricky, you'll find that the product rule is a better strategy. But for this one, maybe you wanted to expand first because they're both linear and then differentiate. It might be easier. So you're going to find this point where the product rule becomes the better strategy but sometimes it's not the best strategy. Sometimes expanding is better. Have a go at your turn now. Pause the video and press play when you're ready to look at the answer. So here we go. I'm going to call this one f of x and this one g of x. And here we go. You should have dy by dx is equal to, now f dash x is going to be negative 2, and then g of x, 3x plus 2, plus you've got 3 lots of negative 2x plus 1. Next we expand, negative 6x plus, got a negative there, take 4, and then you've got take 6x plus 3, bring our like terms together, negative 12x, and then you've got to take 1. So there we go. Hopefully you got that answer there. Let's move on to the next one. And as you can see, product rule is going to be probably better here because they're getting harder. Let's use our different notation. Let's use u and v now. And let's use our rule y is equal to u dash v plus v dash u. Okay, now unfortunately I've used these letters there. If you draw u and v similar, you probably want to be careful with this notation and just make sure they're really obvious. Let's differentiate. So y by dx is going to be, u is going to become, u dash is going to become 3, then v, we put that in, x squared plus 5x takes 7, and then we plus, and you've got v dash, which is going to be 2x plus 5, and then we times by 3x take 5. Let's expand that and let's see what we get. 3x squared plus 15x take 21 plus 6x squared take 10x, and then we go plus 15x take 25. Let's bring that across like that. Okay, and let's collect all our terms there. So I've got 9x squared, and then I've got 15x take 10x plus 15x, that's going to be plus 20x, and I've got negative 21 take 25, which is going to be take 46. There's my answer. What I'd like you to do is have a go at the one on the right, x squared plus 4x times by 2x take 3. So pause the video, have a go, and then press play when you're ready. So we're going to have a look at this. I'm going to use u again, and I'm going to use v, and let's find out what we get. F of x is equal to 2x plus 4, that's u dash, times by 2x take 3, plus, and then you've got 2 lots of x squared plus 4x. Expand, and we've got 4x squared take 6x plus 8x take 12 plus 2x squared plus 8x. If we collect all our terms together, we've got 6x squared, and then we've got 16x take 10x, which is plus 10x, and then we're going to go, I think it's just take 12, and there's our answer there. Hopefully it went well there. In the next situation here, in the next video, we're going to be, oh no, we can just keep going. We're going to be looking at problem solving with a product rule. Okay, so here we go, problem solving the product rule. Consider this function here, find the tangent for f dash of a is equal to 69, where a is greater than or equal to 0. So first thing, we need to find a tangent, so we're thinking y is equal to mx plus c, and we know that the gradient at x is equal to a is going to be 69. Okay, so how about we differentiate this function? Let's call this u, let's call this v, and let's differentiate. F dash of x is equal to, and then we differentiate u times by v, then we add together v again, which is the differential of that, so that becomes 2x plus 1. Sorry for my scrappy working. 2x plus 1. Oh, look, we got a repeated root there, and let's collect our terms. 2x squared plus 2x take 4 plus 4x squared plus 2x plus 2x, which is plus 4x plus 1. Let's collect those. 6x squared plus 6x, and the negative 4 plus 1 is take 3. Okay, so what we now have is we want to make it equal 69. So we want to find out for what value of x does it make a gradient of 69. Now we can solve quadratics by using the null factor law. Let's bring everything to one side. So this is going to be take 69 both sides, so take 72. Now we don't really like monics, so we can make this, non-monics, we can make this a monic by taking out a factor of 6 across the board. Then we can cross it out. And what can we do with this? Well, we can factorize, hopefully. Yes, we can. It's going to be x plus 4, x take 3. Therefore, x is equal to negative 4 and positive 3. Now it says for when a is greater than or equal to 0. So what are we going to do with that negative value? We're just going to cross it out. Okay, so we're only looking for x is 3, y. We're looking for a values that are greater than or equal to 0. Now what we probably should have done here is replace these with a's. So we'll just go a is equal to 3. What we're going to now do is we are going to find our tangent. So we can go y is equal to mx plus c. Now we know the gradient already at this tangent is 69. And now what we need to do is we need to find the y-intercept. Now, as usual, we simply just need to find a coordinate. So this is our original function up here, isn't it? So if we sub in x is equal to 3, then we can find the coordinate of what this tangent passes through. So let's move on and let's sub in 3 into that formula. F of 3 is equal to 2 lots of 3 plus 1, and then 3 squared plus 3 take 2. So I'm just subbing into that f of x rule there. What comes out, you've got 7 in this bracket, and then you've got, I believe it's 10 in the other bracket, so 70. What's our coordinate? 370, and let's sub that in to our equation here. So 70 is equal to 69 times by 3 plus c, and what comes out? C would have to be negative 137, so we've got our rule, 69x take 137. Fair bit of work in that one there, but that's like a more problem-solving kind of question where there's a lot of marks to do a question like that. Thanks very much. I hope you found this video useful, and thank you for your time.